Hello guys, we want to look at introduction to electrostatics, and we are going to be looking under this. We are going to look at electrostatics definition, electromagnetism, electric charge, looking at it in its fundamental attribute, and looking at the intrinsic property of it. Then look at what examples of electrostatics, and look at what confirmation of Franklin's from 1970, which was done in 1706 to 1790. His experiment. Then what about what the two fundamental principles of charges. Now let's start. Electrostatics is what is defined as what is study of what of discrete charge at rest. So when you are talking about what the study of discrete charge at rest, or you can say that what electrostatic can be what? It can be what? Talk about what? The electrostatic charges. Static what? Charges creating what? Electric what? Field in what? Its surrounding space. So that means that electrostatic, it can be what? Can be what? Deal with what? Study of static charges. Let me put it this way. It can be what? Study of what? Study of static charges creating electric field in its surrounding space. So when you are talking about the study of static charges that is creating an electric field in its surrounding space, we say is what? The study of electrostatic. Excuse me. You can also say that electrostatic is the study of charge or discrete charge at rest. So when we talk about electro is talking about the charges. Then static has to do with rest. So basically, study of charge at rest is equal to what? Is what we call electrostatic. Now let's move to the next one quickly. Electromagnetism. Electromagnetism is what? The study of what? Electric field and what? And magnetic field interaction. So when you are talking about electrostatic, you are talking about the study of discrete charge at rest. But when you are talking about electromagnetism, you are talking about the study of electric field, and magnetic field interaction. So how electric field excuse me, and magnetic field interact in a field. Now, what brought about what? Electric field. Now, static charges, or what we call static charges, create what? Electric field. Please take note of that. It's a vital point. While moving charges create magnetic field. Create what? Magnetic field. These are vital points you should know. You should not play with. So that means that the study of static charges and moving charges is what we call electromagnetism. So that means, because we are trying to see how does electric field come into play in what? Electromagnetism. How does magnetic field come into play in what? In electromagnetism. That means the study of static charges created by electric field or moving charges created by magnetic field, and when they experience force when they are moving towards an external world, when they are moving towards an external world field, they create force. So that means that if a moving charge is trying to go into an external field, it now creates a force. They experience a force. We call them, that force is a Lorentz force. as you go along, because you get to know about Lorentz force. So create a force alongside with it. So that is what we call what electromagnetic field. With the moving charge create magnetic field, static charge create what electric field. That one is explained already. Now what about charges? Charges, electric charges are what? Are fundamental what? Attributes. Attribute of what? Particles on which what? Matter is made. They are fundamental attributes on which matter is made. Now, let me basically break down something for you. Let me break this something down. Now, you remember quickly that particles combine together to give you an atom. Atoms combine together to give you molecules. The molecules combine to give you matter. This is the growing what? Movement of from particles to atom to molecules to what matters. And won't forget that electrons or charges basically falls within what, especially elemental particles like what? Electrons, protons, they fall under particle. They are subatomic particles to what? To an atom, which we are still going to look at. So don't forget also, we can say charges are what? Charges are what? Are intrinsic what? Intrinsic property on which what? Matter is made. So it's an inbuilt property. Inbuilt, intrinsic means what? It is the what? The property of the charge is determined inward, not by the external factor. So the charges properties are determined inward, internally, not externally. And that is why if you want to measure what? The instrument used to detect charges, we use what they call a gold leaf electroscope. Electroscope. A gold leaf electroscope is an instrument used to detect charge. It's used to what? It's used to detect what? Charges. Please don't forget. Gold leaf electroscope is an instrument used to what? To detect electric charges. Just a rough sketch. It has a what? A metal cap. Then it has a leaf. Then the case. You understand now? Then you have what? What they call this is the leaf, the gold leaf. The leaf here, which can diverge and what? Also converge, depending on the what? This there is a cap here where you place your this. This is what? Just more or less like insulator that is connected to the what? So that is just that. So it's just rough sketch of how gold leaf electroscope is. Now, that on the cap, you cannot place or charge. If it is positively charged and you place a positive charge, it will diverge. If you have a what? A negative charge and it's what? Is positively charged, it will close up or probably reduce in divergence, because opposite charges will make it lead to reduce, but like charge will make it enlarge or open up the more. So all these things are what we did in O level what? Physics. Now, but basically, gold leaf electroscope is used to detect what? Charges. Don't forget about that. Now, we have talked a little bit about charges. Let us talk about what this man talked about, which is Benjamin Franklin. He's saying that what? When you take a glass rod, when you rub with it what? With silk, it will produce a positive charge. That means that glass rod will be positively charged. Then when you now bring two glass rods together, they will repair each other, because like charge repair, while unlike charge attract. So glass rod will now repair each other. When you bring two glass rods together, they will repair. And then when you want to charge ebonite, maybe ebonite rub with 4. Ebonite become negatively charged. When you now bring these rods of ebonite together, then you notice that they are repairing each other. It means that they are like charges. So please don't forget, when what ebonite rub with what, with 4, it what, the ebonite what is negative, but when what glass rod is what is rubbed with sick, is sick, the glass rod will now become what, positively charged. The glass rod positively charged. And what this man confirmed to us, that he also confirmed from this experiment, although the confirmation was properly done by Columns law, which is like charge repair or like charge attract, but this man performed an experiment get that is close to it. You understand me now? That explains this particular word, like charge repair or like charge attract. But Columns law were able to confirm and be able to bring out something, out from this experiment to tell us that like charge repair while like charge attract. Now, one wonderful thing is that you can try that too. You can take your pen, the slippery part of that your pen, rub it on your hair. You understand that? You can use it to pick a piece of paper on the table. That means when you place a piece of paper on the table and use a pen to rub that slippery part of the pen, to rub your head, rub it. After rubbing it, then use it to what? Make sure the air is dry. Then you can use it to pick a piece of paper. That means that is a good example of what? Of electrostatic. Because we are talking about example of what? Electrostatic. That is an example. Then from this example, we now also confirm that you can create charge by rubbing. Because this is friction. By rubbing one word, particular word or object against the other. There might even be an insulating bodies, but at the end of the day, you see them generating what? Creating charges. They are static charges. And when it involves static charges, we are talking about what? Static. Because electrostatic what? Is what? It points towards what? Explanation or study of static charges that create an electric field around a surrounding space. So that is what they do. Now, another thing again you must understand is that, please take note of this. Now, the net charge of ebonite rubbed with 4 will be 0. The net charge, because for this ebonite to possess negative, that means the 4 will have possessed what? Positive. Don't forget that for this ebonite to possess negative, it means that there is a transfer of electron. And then one transferred electron, which is to become what? When electron is being transferred, the place where the electron is accepted is become negatively charged, while the one that release electron become positively charged, which we all know. Now, if you don't know it, just know it now. Now, the next thing to talk about is what? Don't forget, this man's experiment was done between 1706 down to 1790. Now, what he is saying basically now, if we now collect what, try to what? Match the knowledge to what? Columns law. Now, if we have what? Positive charge here, we have another positive charge here. We want to combine them in idea. Now, we notice that they will repair. The like charge will repair because they are like charges. Look at it. They will like charges. Now, in that case, when they repair, it will what? It will go outward. The field direction will move outward. Then let's say we have negative and negative charge here. It will also repair. The two of them will undergo repulsion normally. But in this case, now this one will not be what? Inward. Understand? The direction of the word of field will not be inward for what? So for negative charge. So it is inward for negative charges and outward for what? For positive charges. Take note of that. It is inward, although the two of them shows what? Repulsion. They show repulsion. So in that case, don't forget. But what about a case where they are unlike charges? Where they are unlike charges. Where they are unlike charges. Now, if you have what? Two unlike charges now, unlike charges, what happens is that, look at the word. Now, it will move from positive to what? Negative. That's what will happen. It will move from what? Positive to negative. This will be outward. And this one will be what? Inward. So it will move from, this is what we call attraction. Attraction occur. Why this one repulsion occur? But check the direction of the arrow from positive toward. That means direction of field actually move from outward from the positive charge. This is the positive charge, and inward towards what? The negative charges. The statement that is outward from the positive charge and inward with what? Negative charge. This is attraction. So we can a charges can be what? Field can create an attraction when this what involve what? Two opposite or like charges, and field can create what? A repulsion when it involve what? A what? Like charges, either positive and positive or negative and negative. So these are things we have talked about. From here we have been able to confirm something there. Now don't forget that I told you that this man experiment was a little bit close to what this thing is talking about. But the man that talked about was like charge repair, like charges repair, why what? Unlike charges what? Attract. Now that is just that. Unlike charges attract. Like charges repair, while unlike charges attract. Now there are some things we also need to know about what? Charges. Now don't forget that charges can what? We have charges can be created. We can form a positive charge is what? As a result of what? What? Loss of electron. So a positive charge is as a result of loss of electron, while a negative charge is as a result of gain of electron. The process of gaining and losing electron is what we call ionization. The process of gaining or losing an electron is called what? Ionization. So that process of gaining or losing an electron to be what? Is what we resort to what we call ionization. So when let's say this is an atom, and that atom loses an electron, it becomes what? For example, sodium, for example, as it lose electron, become what? Minus one electron, it become what? Sodium plus. So, and that's why we write it like this. This is how they write it in chemistry. If you go you write like this. Then if what? Chlorine gain an electron, for example, it become chlorine minus. Now that means to say that positive charges, that means charges are two types now. Two types of charges. Two types of charges. What are there? You have the positive charge and what? The negative charge. So the process of what? Losing an electron or gaining an electron result to these two. And these are the two types of charges that we have. There are two types. How do you get positive? When electron is being lost from the atom. How do you get negative? When electron is gained by the atom. So, and this gaining and losing of electron result to ionization. Now, what about ionization energy? Ionization energy is the minimum what? Energy required, the least energy required to remove an electron from an atom. This is what we call what? Ionization energy. Now, if you are talking about an atom, I just mentioned an atom. I've been talking about atom. What is an atom? Look at this. This is an atom. Then inside the atom we have the what? Enclosed what? By the nucleus. This is the nucleus. We have the proton inside the proton, and we have the neutron inside the nucleus. Then at the surrounding we have what they call electron. So what are the subatomic particles? Now don't forget that neutron is what? Chargeless. Chargeless particles. It's a particle. We have what? Proton is what? Positively charged. Charged particle. While electron is what? Negatively charged particle. Now, the 2,000 times of what? The mass of what? Of proton and neutron inside this nucleus is 2,000 times the mass of electron at the outer shell. I said the mass of proton and neutron inside the nucleus of an atom. This is where the mass of what? Of an atom tends to be more concentrated. The mass of an atom tends to concentrate at the nucleus of in the nucleus of an atom. Why? Because the mass of proton and neutron in an atom is about 2,000 times the mass of electron at the outer shell. That resulted to 99% of the mass of what? Of an atom is concentrated at the what? The central core of an atom, which is the nucleus. And this is a statement by what? Made by Rutherford. So in that case, that means that 99% of what? Of mass of an atom is concentrated at the central core, the nucleus of an atom. Inside the nucleus, we have the proton and we have the neutron. Now, in this case now, let us look at a chart that explains what? The mass, the charges of neutron and proton. Quickly, let's do that. Now, we have a table. Let's say we have a table like this. Now, this table is what? Let's say the particles involved. Let's say we have the particles. We have the proton. We have the what? The electron. And we have the neutron. Now, don't forget that the mass of proton is about 1.622 what? 1.6724 thereabout times 10 power minus 27. But mass of this one is 1.22 what? 79 something times what? But take note of that. The most important, they will always give you your exam. But in this case, the mass of neutron is higher than the mass of proton by some fraction. Understand me? By some fraction. So, but the mass of electron is about 9.1 times 10 power what? Minus 30 what? 1 kg. Don't forget there is kg. Now, this mass of what? Mass of particles. Then what about their charges? The charges are what? This one is what? Plus E, this is minus E, and this one no charge. Don't forget, no charge. The proton has a plus E, which is 1.6 times 10 power minus. Don't forget, E is what? 1.6 times 10 power minus 19 coulomb. That is the electronic charge. One is positive, one is what? Negative. One is positive, one is negative. So don't forget that this table can also help us to be able to what? To know how the what? This one is chargeless and massless. Chargeless, but it has mass rather. Then this one is what? It has mass and also have negative charge. Positive charge, it has mass. So this one is positive, negative, and neutral. Now, I mentioned neutral. An atom can be neutral. A neutral atom is an atom that has the number of electrons equal to number of protons. So when the number of electrons and protons are equal, we say what? The atom is neutral atom. Example of a neutral atom, let's say sodium now, before it loses its electron or loses one electron, we have 11 protons and 11 electrons. Such an atom is what? In a neutral state. Meaning that what? In that case, it's non-reactive. It's in its what? Non-reactive state. Because when a sodium becomes positive, that means sodium ion is more reactive than what? Sodium plus. We are not going there. Now, let's go back. So this is what basically what an atom is talking about. But we have just talked about ionization, talk about this and that. Don't forget there are three things there are some bodies that don't allow electron to pass through them. Example is insulator. We have some material that allow electron to pass through them, because when you are talking about charges, it's not all charges that can lose or gain electron. Now, for example, for you to even lose electron or gain electron means that you must be permitted. You must permit the electron to pass through you. So what are the material? We have three materials basically. We have the conductor. We have what they call semiconductor, and we have what they call insulator. These are three basic materials on which you can explain how electrons flow into them. Now, insulator do not allow what? Do not allow what? What electrons to pass through them. Electrons to what? To pass through them. So insulator do not allow, but semiconductor allow electron to pass through them under thermal influence, under thermal what agitation. That is what for semiconductor. But for conductor, they allow free mobile electron to flow through them. If you check, basically, they don't have a kind of forbidden what band in them, energy band that can disturb the electron from moving from one valence band, which they are this valence region, to what conduction region, where they become conductive. That's why most of the times when we say insulator do not allow electron to pass through, we use them as a dielectric material. Dielectric what material? Insulator majorly are used as dielectric material because they are very good. We put them inside the capacitor, between two parallel plate capacitor. They tend to increase the capacitance of the capacitor. They do a lot of things. But this video, I will just quickly mention a few. Now talk about the three materials that even allow charges to flow through them. We know that charges are measured in columns because some of you are saying C here. The C here means what? Columns, which is what? The same thing as ampere second columns. Now, we have talked about that. Now, let's quickly look at the last part of this, which is two fundamental principles of charge. Two fundamental basic principles upon which charges can be explained or can be properly understood. Now, the first one I will talk about is what? The principle of what? Of conservation of charge. The principle of what? Conservation of charges. Conservation. The principle of conservation of charges. It says that charges can neither be created nor destroyed, but can what? Can be transferred from one body to another. It's also saying that what? The algebraic sum of what? Of charge in a closed body or closed system is equal to what? Zero. The algebraic sum of charge in a closed system or closed body is equal to what? Zero. Now, what is this one saying? Now, if we want to look at it in terms of reaction, now let us isolate what? A neutron. An isolated neutron is unstable, automatically produces what? It decays. Don't forget, a chargeless particle like neutron, when you isolate them, it produce what? A proton plus electron plus what? Antineutrino, a chargeless and massless particle, which is it means that what? This will be what? Something like this. Now, don't forget that this is neutron now. If you check, 1 plus 0 is 1. 1 minus 1 is 0. So the number of what? Charges on the left hand side, this is plus E, this what? Minus E. Plus E minus E will give us 0 charge, 0 charge, 0 E. So in this case now, this one is chargeless and massless. So the total number of charge on the what? On the left hand side is equal to total number of charge on the right hand side. The total number of charge on the right hand side is equal to total number of charge on the product side. When a what? Because this is an unstable what? If you isolate them, they are unstable. If you remove them from the nucleus and isolate them, they are unstable. They will undergo this reaction to produce this what we call anti-what? Neutrino. It's a massless and chargeless particle. We are going to hear more about anti-neutrino under reaction of what? Of radioactivity. Now, after knowing this now, what about other things we can talk about? We have about what? Conservation of charges. Now, if I have a what? A positive what? Or negative rod here, please, that is charged, a charged positive rod. Let me have a what? A conductor here. I have a insulator. Let's say A, and I have another one here, placed side by side in contact B. is B. Now, this is an insulator so that we have to the earth now. Now, if this one now is what? Negatively charged. Now, we notice that this charge can recreate itself, can transfer charge to what? To these two bodies. Now, this particular A will take a what? A positive charge. It will repel, this one will repel itself to the other side, which is negative. When that occur, this one will repel itself to what? To this other side, while you attract positive charge to itself with the same what? Magnitude. Now, with the charge what? Rod, this is charge rod in place, you don't remove the charge rod. If you now separate them, this one will now become positively charged. The A will be positively charged, that is A, while B will be what? Negatively charged with the same magnitude. That is at the end of the day, when you now ensure that this charge rod is still in place, you will notice that A is positively charged with the same magnitude of what? Of the charge rod. B will be negatively charged. What does that mean? It means that charge are being created. You understand that? So it is not destroyed, it is created and that been transferred. So charges can be transferred. And how can charges be transferred? You remember that charges can be transferred by movement of elemental particles like electrons. It is easy for electrons to flow, knowing fully where their masses and their ability to what? To move. Now, basically, let us explain what the second principle, which is what? The principle of what? Quantization. The principle of quantization. The principle of what? Of quantization. The principle of quantization. Quantization states that Q equal to N. What does that mean? It means that the total charge is in or on an isolated bodies is an integer multiple of an electron. Is an integer multiples of an electron. So that is what he's saying. What does that mean? What does that mean? It means that what? That charge is equal to NE, as I stated before, where N can be either be 0, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, and so forth. N can be what? Can be negative or what? Positive. 2, N must what? Must exist as a what? As a whole number that enables electron to be transferred. You know, I was talking about transferring of electron from one body to another. It is easy to what? To transfer minus 2 plus 5e, no, 10e minus 3e. You understand? Irrespective of, because this one can be negative, can be positive. So it can transfer, remove the 0. It can transfer what? Minus or plus. It can transfer what? A whole number. So that means that charges exist as a what? As a whole number. So N must exist as a whole number for easy transfer. So, and these elemental particles that can be transferred from one body to another or from one place to another must exist as a whole number. In fact, that removes what? Quarks. Quarks are what? Are exemptions to what? The principle of quantization. Please take note of that. Principle of what? Of quantization. So if they ask you why are quarks they are exempted from this principle, it's because quarks exist as a whole number in nature. They exist as what? Whole number in nature. Quarks exist as a whole number in nature. What are the two quarks that we have? Let me check my mic, which is working. The quarks are what? We have the what? The up quarks and we have what they call the down quarks. And quarks, what are they? They are fractions of electrons. Fractions of electrons. They exist as fractions of electrons. They don't exist as whole number. We have what they call plus or minus 2/3e. From here, we have plus or minus 1/3e. So up quarks are what? 2/3, which can be positive or negative. Down quarks is what? 1/3. Can electron exist as quarks? Can we have quarks existing in what? No. Quarks actually have their source from the nucleus, from the central core. So electrons is not in the central core. So electron has zero, what we call zero what? Quarks. But neutron and proton has what? Quarks. When we have what? 2/3e plus what? Let's say we have what? 2/3e, then 1/3e. Now, what I'm trying to do now, define the LCM before I tell you anything. It's 3. We would have 2e plus 2e minus 1e. And then we would have what? 3e/3, which is what? E. If you check the table I gave to you, I gave you E as proton. What does that signify? It means that proton has what? 2 positive up quarks and 1 negative down quarks. A proton has what? Proton has what? Has what? 2 what? Positive what? Up quarks. And what? 1 what? Negative what? Down quarks. Please take note of that. 2 positive up quarks and 1 negative down quark. What about neutron? Neutron has how many? How many up quarks and how many down quarks does neutron has? You understand that? You are going to state that in the comment section for me. We have 2/3e, 1/3e, 1/3e. So it has what? 0 electron. Don't forget 0 electron. Okay, don't forget, that's why I put 0 here. 0 initially, because I clean it because I want you to what? Understand. Neutron, proton exists as what? As whole number. You understand now? Proton, neutron, electrons, they what? They follow the principle of what? Quantization. They can be what? They exist as a whole number. 0 electrons. 0 electrons. This one means what? We are going to have 3. At the end of the day, you are going to have what? 2e minus 1e minus 1e. At the end of the day, you are going to have 0e. That 0e means that it's what? That neutron has 1 up quark, positive up quarks, and 2 negative down quarks. 1 positive up quarks, which is 2/3 plus 2/3, and 2 negative down quarks. But electron, does it have a quark? No. Why? Because they are found in the outer shell of an atom. They are not found in the nucleus of an atom, where quarks are what? Originated from. The source of quarks is from the nucleus, which are what? They are particles also. But these particles, did they obey the principle of quantization? No. So quickly, let us expatiate that formula because we don't have time to spend again. We are going to come back for part 2, which is what? Going to talk about what? Coulomb's law itself. So Q equal to what? Ne. Don't forget that Q can also be equal to IT, current times time. Now, we also understand that N is equal to mass over molar mass. Times what? Avogadro's number times Z. So that means that the number of what? This N here is called the number of what? Of electron or proton. You see what I'm like? The number of electron or proton. That is N for you. The number of electron or proton, and it exists as a whole number. Don't forget that quarks is what? Does not obey the principle of quantization. I've told you quantization. I've explained some basic things that you need to know about what? Quantization for you. Now, M is what? Is mass, while M naught is what? Molar mass. Now, don't forget that number of mole is equal to mass over molar mass. Number of mole. So that means that this one is equivalent to number of mole. We have N, A is what? Avogadro's number. Avogadro's number, which is about what? 6.02 times 10 per what? 23 per mole, electron per mole. So that is just that. We have Z. Z is what we call what? Z is what we call what? Proton number or atomic number. Yeah. So in that case now, what am I saying? I'm giving you a formula now that will help you to solve problem on Q. Q can be equal to the number of electron times E or number of proton times E, or equal to what? Current times time, or equal to number of mole times what? Number of mole times Avogadro's number times atomic what? Number times E. It can also be equal to mass over molar mass times what? Avogadro's number times Z times E. So please take on that. This is what a formula you should not play with in calculating what charge using principle of quantization. You can put bomb alongside with it, so which will help us to what? To remember. You can put your red pen to what? To circle this for emphasis purpose. So I believe I'll be able to explain to a reasonable extent, to be able to introduce this topic, electrostatic. When we shall see again part 2, remain blessed and have a wonderful day. If you know you enjoy it, please just click the subscribe button if you are a returning viewer. And if you have been watching, thank you for watching. Please just like the video and make comments so that we can know what to do in next class to make it better. Thank you very much. God bless you. Have a wonderful day.